in this video we are going to study about isomorphism of graphs, right? What is isomorphism? Two graphs G1 and G2, two graphs G1 and G2 are said to be isomorphic when it satisfies some certain number of conditions. Okay, what are those conditions? If I have graph G1 and G2, they are called isomorphic to each other if the number of vertices are same in both the graphs, number of edges are same in both the graph, the degree sequence of both graphs is same, right? So if I have to, if you see this example here, G and H, how many vertices are there in G? 1, 2, 3, 4, 5. So this is G and this is H. So number of vertices, if you see in G it is 5 and in H it is 1, 2, 3, 4, 5. It's again 5. Then count number of edges. So 1, 2, 3, 4, 5, 6. It is 6. Whereas here 1, 2, 3, 4, 5, 6. It is 6. Okay. So the number of vertices, number of edges are same. Now look for the degree sequence. What is degree sequence? First find out the degrees of each of the vertices, then write down the degrees in descending order. So for A, degree is 2 because it is incident with 2 edges. For B it is 2. For C it is 1, 2, 3. For E it is 1, 2, 3. And for D it is 2. So the degree sequence of graph G is you found out all the degrees of the vertices. After that you write down the degrees in descending order. That becomes the degree sequence. So first one is 3, then 3, then there are 2, 2, 2 like this. Now find out degree sequence of graph H. For A it is 1, 2, 3, 4. The degree sequence is 4, right? B it is 2. C has 3. D as 2. E as 1, right? If I write the degree sequence here, 4, 3, 2, 2, 1, right? So degree sequence is not matching. Therefore, we can say that these two graphs G and H are not isomorphic to each other. Now, why do we have to find out this isomorphism? Why do we have to study this isomorphism? Okay, so if there is a graph G1 which is formed, okay, again let us go back to our basic understanding of graphs. There is some general problem. There is one problem P1. Okay, that problem, maybe the campus example where you have to place the fire stations could be one general problem. That problem P1 you are representing as a graph G1. For this G1 you are trying to find out solution. Maybe what should be the minimum number of fire station I should install such that every building, fire station is reachable from every building in 5 minutes or less than 5 minutes. That is the criteria. So that general problem you are converted to graph G1 and you are trying to give a solution for this. Say after doing this, if there exists another problem P2, or a similar problem P1, another one, okay, then you are representing as graph G2. If you are unable to find solution for G2, then this solution which you got here, S1, right, will help us in identifying the solution for this graph G2. Meaning that graph G1 has certain properties. Okay, given a problem, given some constraints, we formed the graph G1. For that we are applying some graph algorithms and finding out a solution, right? If there exists a similar problem, okay, and you with that similar problem is being converted to a new graph G2, okay, it also has some properties which if those properties are matching with the properties of another earlier graph G1 which already has a solution, it is easy to find out the solution S2. So for that the properties here should be same, right? So again there are a lot of applications in detail when you try to solve some graph problems, you will understand what is the use of this isomorphism, right? So two graphs G1 or G2 are said to be isomorphic if the number of edges and vertices are same, the degree sequences is same, and their edge connectivity is retained. edge connectivity is retained means if you mapping A, B, C, D, E, these are the vertices here in this graph. Anyhow, these two are not isomorphic, but if you take isomorphic graph, then which are the corresponding, no, this belongs to G, which are all the corresponding vertices in H which are matching with these no vertices, that we have to find out. Anyhow, this example, these two are not isomorphic. Let us see some more example to understand, to find out whether the graphs are isomorphic or not. Okay, see here the second problem. I have a graph G and H, right? Count the number of vertices, right? G and H. Count the number of vertices: 1, 2, 3, 4, 5, 6, 7, 8. It is 8 vertices. Then in H, how many vertices are there? 1, 2, 3, 4, 5, 6, 7, 8. Again here also 8. Perfect. Now find out number of edges. Find out number of edges in G. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So number of edges here is 10. Here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Here also it's same, 10 and 10. Now let's find out the degree sequences. Find out the degree sequences of both the graphs, right? So first find out the degrees of the vertices. See here, for A it is 2, for B it is 1, 2, 3, for C it is 2, for D it is 1, 2, 3, for E it is 2, for F it is 3, G it is 2, H it is 3. So what will be the degree sequence here? Write down the degrees in descending order. So it will be 3, 3, so there are 4 3s and there are 4 2s. So this is the degree sequence of first graph. Second one, you calculate 1, 2, 3. This is 3, this is 2, this is 2, this is 3, here also is 3, it is 3, it is 2, it is 2. Yes, 4 3s and 4 2s. So the degree sequences are also same, right? So we found out that these two graphs G and H are isomorphic to each other. Okay, then see this example, third example. Find out the number of vertices. Number of vertices is 1, 2, anyhow numbering is given to us. So number of vertices in G and in H, here it is 6, here also number is given 6. Edges, if you see, 1, 2, 3, 4, 5, 6, 7 edges. Here 1, 2, 3, 4, 5, 6, 7 edges. Okay, number of vertices and number of edges are same. Now let's find out the degrees of the vertices. It is 2, it is 3, it is 2, it is 3, here it is 2 and 2. So the degree sequence is 3, 3, then 4 2s. Here in the second graph, if you check, so this is 2, this is 3, this is 2, this is 3, 2, 2, right? It is matching because the degree sequence here is 3, 3, then 4 2s. Okay, so we can say that these two graphs are isomorphic to each other. This is just to represent, when you represent a problem, you had a problem P1. Okay, that problem is represented as a graph and that graph is G. And you are able to find out some solutions for this problem. Okay, in the same way, if there is another problem, which when it is converted to a graph, it is resembling, it is very similar with the earlier graph for which we already solved a problem. Then that solution or the similar approach can be applied to solve this problem as well. To find out the similarities between the properties of the graphs, we check isomorphism of the graphs. Okay, so given two graphs, your logic will be to find out whether they are isomorphic to each other or not. Thank you.